When's an air sweep not an air sweep? Well, let's find out. Paul the air sweep guy, here to talk about straight shooters and how they differ from air sweeps, and where you might want to use a straight shooter in your process to start and keep material flowing. So first we're going to do a quick demo using the old hex nuts and test table to show you the difference between an air sweep pulse and a straight shooter pulse. Then we're going to mock up a chute, put some material in it, and show you the straight shooters in action. But first let's take a look at the design of the straight shooters and show you how it works. The straight shooter assembly and air sweeps share all of the same parts with the exception of the valve head. The air sweep valve head has a lip and the straight shooter valve head does not. The lip in the air sweep is what directs the air or gas pulse to spread out perpendicularly, allowing it to travel in a wave along the inner wall and sweep and break material loose. Without the lip, the straight shooter allows the pulse wave to travel in a tight column, straight out in front of the nozzle. Just like the air sweep, the straight shooter is designed to pulse for a very short duration, usually a quarter second, and then instantly reseal to remain dust tight and keep material from feeding back into the nozzle or air supply lines. This makes the straight shooter a very effective tool to disperse material that may be hung up where we can't install a standard air sweep, like in a shared wall in a grain bin, or maybe a place where there's a lot of structural elements and we can't install the standard air sweep. We can install a straight shooter on an opposite wall, shoot across, and get that material hang up to break loose. We also make a mounting that allows us to point the straight shooter in different directions. It's a 45-degree mount, so we can mount it on the top of a chute and push material down the chute, or on the side walls. We can even mount it on the side of a cone, shooting up into a cylinder to disperse material, break a bridge where we can't install that standard air sweep. So now we're going to take a quick look at the difference between the air sweep pulse and the straight shooter pulse. Let's take a look. First up is the model VA06 straight shooter. We can see that the pulse energy is directed straight out from the nozzle in a tight column. The VA06 model has an effective activation range of about 1 to 2 feet directly in front of it, depending upon material and environmental conditions. The closer the nozzle is to the material, the stronger the effect. In comparison, the VA06 air sweep directs all of its pulse energy out to the sides, perpendicular from the nozzle, which provides the classic sweeping effect of material along inner vessel wall surfaces. Almost no energy from the air sweep pulse radiates out in front of the nozzle. Okay, now we have a good sense of what the straight shooter pulse can do. So let's mock up a chute, put some material in it, and watch them in action. Let's do it. Okay, piece of cake. So I put together the chute, and I've already run some tests with the straight shooters. Right now we have this pebble rock in here. It's about 100 pounds per cubic feet. Comes out of the bag pretty wet. It won't slide down a 22-degree chute, which is what this chute's sitting at right now. It won't slide down that on its own. So it needs a push from something like a straight shooter. Now we've run some tests with the straight shooters up top, on the sides, various configurations. So let's take a look at those right now. The first test is with the straight shooters mounted on top of the chute. You can see the pulse hit the top of the material, but it only pushes a little of it down the chute. We'll reposition one of the straight shooters to a low sidewall and see what happens. So now we have one unit mounted low on the side and one unit still on top. The low unit is bouncing off the chute bottom but isn't pushing the pile forward. The top unit isn't helping because most of the material is still behind it. So now we've moved the other unit from the top and relocated it low on the other side. You can see this is clearly the best position for the straight shooters, as they can bounce the pulse energy off the chute bottom and lift and displace the material while directing it down towards the discharge. 2 straight shooters still aren't enough to clean out the entire chute because of the shallow angle. For an application with a shallow slope angle and heavy material like this, at least 2 more units would be necessary around the midpoint of the chute to push everything out the entire way. I hope you found that interesting. Remember, for more information about air sweeps, visit us online at airsweepsystems.com. Until next time, I'm Paul, the air sweep guy, reminding you to keep it flowing.